Hello, this is Ishan Akbar. Welcome to my YouTube channel. In this video, we would discuss the consolidation settlement of a clay layer by dividing the clay layer into sublayers. I have recorded previously two videos, but those two videos have solution for one layer, a single layer. But in this video, I will divide a whole layer in multiple layers in sublayers to make you understand the proper solution phenomena for the consolidation settlement questions. So for this, I have included this is example. In this example, the soil profile is shown on the right side, and a stress is being applied. Let us say this is the foundation, and a stress is being applied by this foundation on the soil surface. This stress is equal to 20 kilopascals. This is 15, not 20. This is 15 kilopascals. The soil profile shown in figure has a stress increase of 20 kilopascals. This stress increase is shown by delta sigma prime. This is increase in stress due to applied load or due to a building and water at a depth of 2 meters below surface. We have a water table, groundwater level at 2 meters below the surface of earth. The dry and saturated unit weights of sand. This sand is dry. Its unit weight is 18 kilonewton per meter cube, and this sand is wet. Its saturated unit weight is equal to 20 kilonewton per meter cube. While clay has a saturated unit weight, this is clay, and its saturated unit weight is equal to 22 kilonewton per meter cube. The pre-consolidated stress is found to be because consolidation settlement is found for clay layer. So we will perform an iodometer test at the middle of the clay layer for its representation, and we have found that the pre-consolidation stress at the middle of the layer was 100 kPa. This pre-consolidation stress is denoted by sigma prime c. It is 100 kilopascals, and original void ratio of the soil is 0.65. Coefficient of swelling is zero point 0.5, and coefficient of compression is 0.05. So these are the values given in the question statement, and now he wants us to find out the consolidation or primary consolidation settlement of the clay by, this is the condition, by dividing it in 1 meter layers. You have to divide this clay layer from this point to this point into 4 layers or 1 meter layers: 1 meter, 1 meter, 1 meter, and 1 meter. So you will divide this whole clay layer in 1 meter layers. So this is basically the division of clay layer into sub-layers for the calculation of consolidation settlement. So I will again draw the profile. Let us say this is the top surface on which a stress increase of delta sigma prime is being applied equal to 15 kilopascals, and water table exists at 2 meter below the surface. At 2 meter we see the water table, and then there is continuation in the sand surface for further 3 meters. This is also sand, but this is dry sand, and this is saturated sand. And next, for further 4 meters, we have a clay layer. This is clay. This is dry sand. This is saturated sand. And unit weight of dry sand, gamma D, is 18 kilonewtons per meter cube, while saturated unit weight of sand is 20 kilonewtons per meter cube. And saturated unit weight of clay, you can see it as gamma saturated 2, that is equal to 22 kilonewtons per meter cube. So your task is to determine the consolidation settlement of this whole clay layer. We want to calculate the SC. Below the clay layer we have rock, so there is no settlement along in this rock region. So we want to calculate the consolidation settlement, but we cannot consider this clay as the whole layer. So for this purpose, according to the statement of the question, or if there is no given statement for for division of layer clay, so you can divide yourself to calculate the accurate answer. If you want the accurate answer of consolidation settlement, you will get the absolute answer for the consolidation settlement. If we divide this whole 4 meter into point 0.5, point 0.5, and point 0.5 meter layers, our answer will be accurate as compared to 1 meter layers. It means if we divide, as we increase the number of layers of the clay, our answer will be more accurate, and if we decrease the number of layers, the accuracy of the answer will decrease accordingly. So simply, according to condition of the question, we want to divide this clay layer into four sub layers of 1 meter each. You can change the depth of each layer. You can keep top layers of zero point 0.5 meter and zero point 0.5 meter, and again next you can increase the depth of the layer 1.5 and 1.5. Simply according to question, we have to divide the clay into 1 meter layers. So simply we'll keep that right this like this one, 1 meter, 1 meter, and 1 meter. So before going to solution, I would like to show you three formulae. This formulae is for this formula is for normally consolidated soil, for which sigma prime C is equal to sigma prime naught. Mean effective vertical stress at this time is equal to the pre-consolidation stress of the soil. And this condition seldom occur. It does not occur every time or most of the times, but this is a rare condition. So next condition is for over consolidated, and this is known as over consolidated case number one. So this is the case. This case is called the case NC. This case is OC1. For this we have formula of CS. See here for normally consolidated soil, we have coefficient of compression, while for over consolidated case one we have yes. This and third one is for the over consolidated, same over consolidated case, but this is case number OC2. So what are conditions to use this formula and this formula? Simply if sigma prime plus delta sigma is less than sigma prime C, then you will use OC case 1, and if sigma prime plus delta sigma is greater than sigma prime C, then you will use second case. This last one, OC2. This is second case. This one is the second case of over consolidated soil, and this is first case of over consolidated soil, and this is the case of normally consolidated soil. So this condition does not occur most of the times. So mostly we see application of this in these conditions. You can apply this if if the description of the questions here is you to use the normally consolidated clay art etc. So to apply these formulae we need some values from the given statement of the question. We need CC if we want to apply this formula. Come to this formula. This third formula has everything which we would need in these calculations. We need CS, it is given. H height of each layer means now we have four layers: layer number one, layer number two, layer number three, and layer number four. So every time we will use a new formula. That may be formula number one for normally consolidated clay, formula number two, or formula number three. But you will use these formulae four times. For layer number one, you will use different formula, or you may use a formula. For layer number two, you will use again the formula. You will choose the formula which formula you will use. This is your choice according to the concepts, according to these conditions. Condition one, two, and three. These are three conditions, and then you will use a new formula for layer three and then for layer four. So you will use four formulae of SC to find out the total consolidation settlement. So simply we will do consolidation settlement of layer 1 plus consolidation settlement of layer 2 plus 3 and layer 4. This will give you the final answer. So we will simply solve this question by layer, by dividing it into layers. So, and then we need E naught is the original void ratio of the soil. We need sigma prime, sigma C prime, that is given as 100, that is equal to 100 kPa. E naught is equal to 0.65. Each for each layer. See here, the height of each layer is 1 meter. It is not 4 meter. Forget 4 meter. This is not available. Let us see this is not. Let us say this is not available. So H for first layer is 1 meter. For second layer it is also 1 meter. For third layer, for fourth layer, total height of the layer, clay layer, that is 4 meter. For every possible case, it is 1 meter. It may be different. It may be same. We have sigma dash naught. We will need to calculate this effective vertical stress at each point, at each midpoint of the layer. We have four layers, so we will need four values of sigma prime, sigma naught prime. This is vertical effective stress at mid of each layer. And then again we have CC, we have H, we have E naught. We will calculate four values of sigma prime naught, and delta sigma is given as 15 kPa and sigma prime C is given. So basically our main task in consolidation settlement questions is to calculate sigma prime naught and then find which formula is applicable to our condition. These are just, you have two tasks. These are very simple questions. The first task, step 1, is to indicate the midpoints of each layer. We have made four layers, so we will indicate four midpoints. So I will do here in this step to make you understand everything. Let us say this is the surface, this is the water level, this is end of the sand, and this is end of the clay layer. So now we have to divide this clay layer into further layers, four layers. Let us say this is part 1 or sublayer number 1, this is sublayer number 2, and this line divides the sublayer number 3 and 4. So right here 1, 2, 3, and 4. Just write down gamma. Gamma D, this is equal to 18 kilonewtons per meter cube. This is water level. This is gamma saturated 1. This is soil 1 or gamma sand. You can say at gamma sand 1. Yeah, sorry, gamma saturated 1. This is 20 kilonewtons per meter cube. And this whole clay has a unit weight of gamma S2. Saturated unit weight of second soil is 22 kilonewtons per meter cube. Just write these values only. Go step by step, you will understand everything clearly. This question will become a mouthpiece. Just stand with the first layer. This is the first layer. What is the height of first layer? This is 1 meter. This is 1 meter. Write down the heights above the clay. This is 2 meter and this is 3 meter. So height is 1 meter. So what is height of midpoint of this layer from this point? From top of the clay layer. This will be 0. Obviously, it will be half. Now indicate the midpoint of the second layer. This is the midpoint, and calculate its distance from top of the clay. Always for midpoint of each layer, always start from the top of the clay layer. Simply. So what will be this height? This will be 1 meter from this point to this point and 0.5 this one. So it will be 1.5 meter. Then because this is also 1 meter. And now go to midpoint of the third layer. It will be, it is also 1 meter. So what will be depth of this point from top of the clay layer? 1 meter plus 1 meter plus half of this, because this is half. So it will be 2.5 meter. You can say M1 midpoint 1, midpoint 2 and midpoint number 3. So what will be midpoint number 4? This one. What is distance from top of the clay? This will be M4 and this is equal to 1 plus 1 plus 1 and fourth rail is of also 1 meter. So you will add half of this 1 meter, zero point 0.5. This will be 3.5 meter. So when you have done this indication, when you have indicated the midpoints of each layer, then you need to calculate four values for static stress. 1, sigma naught 2, sigma prime naught 3, and sigma prime naught 4. Simply, how will you calculate sigma naught 1 prime? Simply start from the top of the surface and go to the midpoint of the first layer. You need to just calculate the stress, effective stress, vertical effective stress. How will you calculate? Just go layer by layer. From this point to this point, the unit weight of the soil is 18. What is depth? This is 2 meter. Plus, from this point to clay, till clay, this is 3 meter. And what is unit weight? This is 20 times 3 plus. What is height from this to midpoint? This is zero point 0.5. You will write 22. This is the unit weight of clay into zero point 0.5. This is not effective stress. This is total stress. You have to just subtract the value of water. What is unit weight of water? You will take 10. You may take it as 9.81, but here for simplification, I will use 10. This is gamma W. Multiply by what is height of water from above this midpoint, because we are doing for layer 1 above this. What is the height of water? 0.5 this one and 3 this one. 3 plus 0.5, this is 3.5. So simply you will multiply all the values. 20, 18 with 2, 20 with 3, and 22 with zero point 0.5, then subtract 35. This will be 72 kilopascals. So we can write that this effective stress is 72 kilopascals. 72 kilopascals. Sigma prime is this sigma prime This sigma prime is the vertical stress increase at mid of each layer. So at mid of first layer, the stress increase is 72. Now you can again continue for second layer, second midpoint. Now this is the second midpoint. So for second midpoint, we need to go this point from surface. Just start from surface and stop where the unit weight changes. The unit weight of top 2 meter is same, so we'll write 18 multiplied by 2 plus. From this point to this point, the unit weight is 20 and depth is 3 plus. From this point to midpoint, the depth is 1.5 and unit weight is 22 multiplied by 1.5, and subtract the height of minus subtract the pore water pressure. This is 10 unit weight of water into height of midpoint is 1.5 meter from, height of midpoint from water table. So water table is at a height of 3 meter plus 1.5. This will be 4.5. So simply this will be 84 kilopascals. So at this point, the stress was 72. At this point, the stress is 84. Now going to this point, third, this will be 18 into 2 plus 20 into 3 plus 22 multiplied by 2.5. This one for soil. This is total stress minus, when you are going to subtract water, then you have to calculate the distance of this midpoint from water surface. After minus, you will have to consider the distance of water and the point. Water and point From this point to this is 3 meter plus this one, it is 2.5. Sorry, this one. So 3 plus 2.5 is 5.5. So the answer will be 96. So at this point, the stress is 96. And again, at fourth point, it is 18 times 2 plus 20 times 3 plus 22 times 3.5 total stress, sorry, and minus 10 into what is height of water. Height of water from this point is 3, this one, and 3.5 from this one point from clay layer. This is 6.5. This will be 108 kilopascals. Just calculate with the help of calculator. When you have found this stress value, this is the most efficient and most difficult task in consolidation questions. Now your question is very easy and you can solve it in seconds, or you can say in minutes. So what will we do? We will prepare a table and we will write the layer number 1, layer number 2, layer number 3, and layer number 4. What is height of layer number 1? This is 1 in meters. It is 1, it is 1, it is 1. All layers are of 1 meter. What is height of midpoint? This Z means height of midpoint. It is 0.5, 1.5, 2.5, and 3.5. This is height of midpoint from the top of clay. What is sigma prime V naught? 72, just write. Sigma prime naught or sigma prime V naught are same. This one and this one are same. 84, 96, and 108. Delta sigma is given in the question. See here, it is 15. Just put its value in the table as 15. Just keep it as 15 because this is constant for whole clay layer or whole profile of the soil. What is sigma prime C? The value of sigma prime C is given to be 100 kilopascal. This is pre-consolidation stress. This one. So put it as 100. Now find out the sigma prime F. This will be equal to sigma V naught plus delta sigma. Just add this number these column 1, 2, 3, 4, 5, 6, 7, 8, and 9. You have to create 9 columns for every question relevant to consolidation settlement. What is final stress? This is sigma prime F, final effective stress. So it is 100 plus, 15. You have to add to get column number 7, you have to add column number 4 and column number 5. Just add these both values. 72 plus 15, this is 87. Then 84 plus 15, this is 99. 96 plus 1015, this is 111. This will be 123. So we have 4 values of final stress. Now check either is there any case for which sigma prime C is equal to sigma prime naught. For any case these two values are not equal. This is 72, this is 100, not equal. This is 84, this is 100, not equal. This is 96, this is 100, not equal. This is 108 and this is 100, not equal. It means normally consolidated case is overruled. We cannot use the normally consolidated formula. We cannot use the first formula. This one. This formula cannot be used. So now we have only two options, formula number 1 for OC1 and formula number 2 for case OC2. For this we need to check this condition. The summation of these both values is known as sigma prime F. If sigma prime F is less than sigma prime C, then we will use OC1, and if sigma prime F is greater than sigma prime C, then we will use OC2. Just check the values from the table. See here, sigma prime F is less than sigma prime C. Sigma prime F is 87 and it is 100. So we will use the case number 1. OC, we will write OC1. Just write this OC1. And now again, sigma prime f is less than 100. So again, case is OC1. Now see, sigma prime f is greater than sigma prime c. So our case will be shifted to OC2. And again, here 123 is sigma prime c is less than sigma prime f. Or simply you can say that sigma prime f is greater than sigma prime c. So the case is OC2. Till this point, the question is difficult, you can say. And all these values and whole the table, you just need to work for three things. First thing is this: find the midpoints of each sublayer of the clay accurately. Column number 4, find out the vertical effective stress for each midpoint accurately. Then determine the total force or total stress, final stress for each midpoint by adding both of these values. This is given. And now the important task, final task, is to determine the case. If you will determine the case wrongfully, then your question automatically will be wrong. Now we have determined the cases. Now we will apply the formula for each point. Now I will go for layer 1. What is the case for layer 1? This is OC1. What is the formula? This SC is equal to CSH over 1 plus E naught log of delta sigma over sigma naught. This one, OC1, this formula. So simply put the values for layer 1. This will be SC1, H1, sigma prime 1, and this one. For first layer, you will put all the values for first layer. What is value of CS? This is zero point 0.5. This is given in the question. 0.5. Just put the value into H. Height of first layer is 1 meter. 1 plus E naught is a value of 0.65 log of. Just simply put the value of sigma prime f, because when these both get added, so the answer is sigma prime of for first layer. So for first layer, sigma prime f is 87. Just put 87, and for first layer, sigma prime naught is 872. So what will be the answer here? 0.5 times 1 divided by 1 plus 0.65 times log of 87 divided by 72. The answer will be 0.0249. 0.0249 meters, because the value of h is in meter. So the answer of consolidation settlement will also be in meters. You can say 249 millimeters. By multiplying this value by 1000, it will be converted into millimeters. Now what is the second case? See, we have found the SC1. It is 0.0249. Just go to table and write here the value of 0.0249. Then go to second layer and apply the formula. Which formula is to be applied for the layer 2? Simply for layer 2, what is the case for layer 2? This is again OC1. SC, same formula will be applied. So just put the values. Zero point 0.5 times. Again, the layer depth of first layer, depth of second layer, sub layer is also 1 meter. 1 plus 0.65 into log of. You need to change here. What is summation of both the values? Sigma prime f. This is 99 for second case. And what is sigma prime? That is 84. We will write 99 by 84. So what will be the answer? This will be 0.0216 meters. 0.0216 meters, or simply we can say this will be 24.9. This is 21.6 millimeters. by multiplying with 1000. So 0.0216. So for layer 2, right here 0.0216. Now go for layer 3. This is case OC2. OC2, and for layer 4 we have also sub layer 4 we have is OC2. So simply we'll write the formula. Oh, sorry. Just consider the layer 3. The case is OC2, and formula for OC2 is CSH over 1 plus E naught log of plus CCH over 1 plus E naught into log of sigma prime F over sigma prime C. So just put the values. This will be SC3. We're going into last slide. This is SC2 for layer 2. This is SC3. Just put down the formula values. CS is zero point 0.5 times layer of height of third layer is 1 meter. 1 plus 0.65 into log of what is value of sigma prime C? It is 100. And for third layer, the static stress is 96 plus CC is 0.05. H is 1 meter over 1 plus 0.65 into log of what is sigma prime F for third layer. Summation of both the stresses, this is 111 and sigma prime C is 100. So you need to just solve this 100 over 96. The first part is 0.00. This has two parts, 0.0054 meter, or this will be 5.4 millimeters. Oh, sorry. This is first part. Answer of this part is 0.0054 plus we have to calculate this part as well, and the answer of this part will be this is 0.0014. 0.0014, and when we add this one this will be 0.0068 meters, or you can say 6.8 millimeters. So for going in table you will write 0.0068 meters. Just write values of SC in table in meter units. Now going to fourth layer, you need to calculate. Again, you will apply the same formula for the calculation of consolidation settlement, and you will find an answer. I will directly write the answer by just putting the values in the formula. Just 100 divided by. Oh, just I will solve as as a whole so that you can see a new thing. So for SC4, when we put the formula values in this part, it will give a negative answer. So don't worry if you get a negative answer. 101 meter plus. What is the answer of this part? We will find out the answer of this part as sigma f is 123 and divided by what is the value of sigma prime c? This is 100, and the answer is 0.00272. So we'll add up these values. 0.00272 minus 0.0101. This will be minus 0.00738 meters. You can say that minus 7.38 millimeters. So just write its value in minus 0.00738. It means the settlement is zero for this case because settlement can never be negative. Uh, this means that there is a swelling of soil due to applied load, but you can ignore its value and you can write it as zero. And if you want to write, there is no big deal, you can write. So, what is total settlement? What is total primary consolidation settlement? You will add up all the values. Simple. First value 249 plus second value 0.0216 plus third value 0.0068 and the value will be 0.04592 meters. And if we want to convert this into millimeters, we'll write simply 0.04592 meters or multiply it by 1000, it will be 45.92 millimeter, approximately equal to 2 inches. This is less than 2 inches. You can say this is approximately equal to 2 inches. So this is how you can calculate the stresses of settlement of the consolidation settlement of the clay layer. And other case, if you have a clay layer of same 4 meters and you want to divide it into 5 layers or 6 layers, so you can divide it like this one. First layer will be zero point 0.5 meter, second layer of zero point 0.5 meter, third layer of zero point 0.5 meter, fourth layer of zero point 0.5 meter, and this layer is 1 meter and this layer is 1 meter. Always keep the top layers as smaller layers and bottom layers as larger layers. It will give you exact answers. If you will keep upper layers as larger or greater layers and lower layer as smaller layers, your answer will be disturbed. So keep this criteria in mind, and then keep that how to indicate the midpoints of the layers. So midpoint of this layer is at a distance of 0.25 from the clay, top of clay. Midpoint of this is how much? 0.5 this one, and half of this layer 0.25. This will be 0.75. What will be midpoint of this layer? Half this one, and half of this layer mean zero point 0.5. Half of zero point 0.5 is 0.25. This will be 1.25. Again, half of this layer will be 1.75. Half of next layer. See, this layer is of 1 meter. So 2 meter and half of this layer, midpoint of this layer will be 2.5 meters. 2 meter, top 4 layers, and half of this will be 2.5. And again, the last layer, sixth layer, will have a midpoint at a distance of 3.5 meters. So midpoint, location of midpoint depends only upon your layers. It does not have any specific rules. It depends upon your intelligence, that how you deal with the things. Thank you very much. See you soon with the next lecture. Take care.